Today is our last day of notes of the entire school year. We're going to be doing our quarter 4 Acuity review in preparation for our final on Friday. We will take our last test of the year on Friday. So this quarter, one of the first things we talked about was trigonometry. With trigonometry, we had a way to remember the trig formulas. You do need to have the trig formulas memorized. We remembered them using SOHCAHTOA. So, standing for sine theta equals opposite over hypotenuse. Ca, standing for cosine theta, equals adjacent over hypotenuse. And TOA, standing for tangent theta, equals opposite over adjacent. With most of our trig problems, we ended up doing word problems, and that's what you'll see mostly on the Acuity test is various word problems. So our first example is a ladder leans against a building. If the ladder is 20 feet long and forms an angle of depression, I'm going to change this angle to a different angle so that it'll work out a little bit. It's kind of weird to have them both 20. Forms an angle of depression of 15 degrees with the building. How far away is the base of the ladder from the building? So with any word problem, it's very good to draw a picture if a picture would apply. This one we have a building and a ladder. Let's draw a picture of that situation. If you didn't finish writing the question down, you might want to pause, finish writing the question, because when I scroll down, you won't be able to see most of it. So we need to draw our picture. We know we have a building. We have a ladder leaning against the building. And between these two things, they form a right triangle. Any trig problem is based off a right triangle. So we have a right triangle involved in our picture. Now, according to the problem, we had a 20-foot ladder. And we had a 15-degree angle of depression. Now, even if you're kind of weirded out by the word depression, it says an angle of depression with the building. So we need the angle that is touching the building. Well, the angle at the top of the triangle is the only one touching the building, so that angle is 15 degrees. When they say depression, it just means you're looking down instead of up. Then the last thing we need to label is what we're looking for, x. So it said, how far is the base of the ladder from the building? That would be the bottom line. So we're going to label that x. Once we have our picture, then we can label opposite, hypotenuse, and adjacent. If we're going to use our trig, we need to label those things. Hypotenuse was always across from the right angle. Opposite was across from the angle given, across from theta, which if they didn't mark something as theta, they marked it with the angle measure. They gave us 15 degrees. Adjacent is whatever's left over. But we didn't even need to label adjacent because we're not going to use it. So we have opposite, we have hypotenuse. According to SOHCAHTOA, SO uses opposite and hypotenuse, which is sine. So we have sine 15 degrees. It's opposite over hypotenuse. Now we just need to solve this for x. We need to get x alone. So we multiply both sides by 20. Now the 20 sine 15, we just plug into a calculator. If you have like a graphing calculator, you can just go in order. If you have like an iPod, you have to do 20 times 15 sine equals. Whereas a graphing calculator, you just do 20 sine 15. So 5.1764. Okay, so that's most of what we need to know for trigonometry. You will also have to use your trig table. Hopefully you still have that trig table that I gave you at the beginning of the quarter. And you will have to use inverse. Remember, inverse was when you needed to get rid of sine, when you needed to do the opposite of sine or cosine or tangent. Next, we had probability. We started probability with trying to figure out the total number of combinations of things, because when we do probability, we have to find the total number of ways to make the bottom of our fractions. So we had two possible things. We had permutations when order matters, say like when you're running a race or a presidential election. Combinations, order does not matter, say like when you're voting for a committee, things like that. With our permutation, the formula is NPR. N stands for permutation, P stands for permutation, N stands for total, R stands for how many we're going to pick. And the formula ended up being N factorial over N minus R factorial. Combination was N factorial over R factorial times N minus R factorial. So combinations had that extra R factorial. And when you go to plug combination into a calculator, you must remember this extra set of parentheses that will not be written on the formula. Now these two you don't need to have memorized. You will have a formula sheet on Friday. So our second example. For the summer, you need to read 5 books from a list of 20. How many different possible combinations of books could you read? What different 5 books could you read? So we have to decide, does order matter or not? Is it a difference reading A Tale of Two Cities before The Stranger, or does it not matter what order you read them in? So if you think about it, it doesn't matter what order we read them in, because as long as we get them done before the end of the summer, we're good. This would be a combination. So we've decided, yes, this is a combination. The total number of books we have is 20, and we are picking 5 of those books. Then we go plug them into the formula. We have 20 factorial over 5 factorial times 20 minus 5 factorial. It will be much easier to plug into our calculator if we minus the 20 and the 5, so we have 5 factorial times 15 factorial. And then don't forget, when you plug it into a calculator, to include parentheses around the denominator, or else this will not work. So all your calculators should have a factorial symbol. The iPhone, it's just on the screen already. It says X exclamation point. On the iPhone, the button would look like this. On some of yours, you may have to hit second first to get to the exclamation point. On like a graphing calculator, you have to go to math and scroll over to probability. Whichever way your calculator is, you go plug that into the calculator and you should get 15,504. So there's 15,504 different ways you could pick those 5 books. It's a lot. Okay, our last thing was probability. We learned how to count the total number of ways of things so we could apply it to probability, which we didn't have to every time, but it could be applied to probability. So this time the giant P stands for find the probability of an event, find the probability that something will happen. And we find probabilities by taking what we want to happen and dividing it by the total number of ways something could happen. So here's our last example. A bag contains 5 red marbles, 2 black marbles, 6 green marbles, and 8 pink marbles. So I gave a part A and a part B. We're actually solving for 2 different things. Part A, we want to find the probability that we get a pink or a black marble if we're picking 1 marble out of a bag. Part B, the probability we get a white marble if we pick 1 marble out of a bag. So we have to put the number of ways we could get what we want to happen divided by the total number of ways we could have something happen. or black. We have 8 pink marbles and 2 black marbles. We could get either of those and be happy because that's what it's asking for. So if we can get either, we have 10 possible ways to pick what we want to happen. Then we have to decide how many ways can we pick any marble out of the bag. So we just add them all up. We have 5 plus 2 plus 6 plus 8, which gives us 21 total marbles in the bag. Now we just divide this to get our answer. If we divide 10 divided by 21, it's 0.476. We want to change that to a percent, so we multiply it by 100, which gives us 47.6. We're going to round to the nearest whole number though, so we're going to say 48%. We have a 48% chance of getting a pink or black marble. Part B, getting the probability of a white marble. Well, the denominator would still be the same, 21. There's 21 total marbles in this bag. We also had some common situation like cards. We have 52 cards in a deck of cards, so that would be the bottom. Or if we roll a dice, one 6-sided dice, the bottom would be 6. If we roll 2 dice, we have a 6 and a 6. We do not add them, we multiply to find the total number of ways. So if we had 2 dice, we have 36 possible ways. We want the probability of getting a white marble. Well, notice there are no white marbles. So we have 0 ways to get a white marble if we pick a marble out of the bag. So that would give us 0%. So tomorrow in class we will do our review assignment. It will be very similar to the Acuity test. And then Friday, wrong day of the week. Friday we will take our final test of the entire year.